Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for f of x equals x squared minus 16 divided by x squared plus 2x minus 8. The first thing to find is the y-intercept, where the function crosses the y-axis. Defined by x equals 0, the corresponding y-coordinate will be found by plugging that 0 into the function for x, so f of 0, which will give 0 squared minus 16 divided by 0 squared plus 2 times 0 minus 8. 0 squared is 0 minus 16 divided by 0 squared is 0 plus 2 times 0 is 0 minus 8. 0 minus 16 is a negative 16. 0 plus 0 minus 8 is a negative 8. The negatives can cancel. 16 divided by 8 is a 2. So the x-coordinate was a 0, and the corresponding y-coordinate is a 2. There's the y-intercept. The remaining parts are found by taking the function f of x, which is x squared minus 16 divided by x squared plus 2x minus 8, fully factoring the numerator and denominator. The numerator is a difference of squares. It will factor into an x plus 4 and an x minus 4. The denominator is a trinomial quadratic, and it will factor into x and x, two numbers that multiply to be negative 8 and add to be a positive 2. It sounds like 8 can be 8 and 1 or 4 and 2, but the 4 and 2 seem to work, so it seems like it'll be a positive 4 and a negative 2. And then canceling out those factors that are the same, resulting in x minus 4 divided by x minus 2. The x-intercepts, where the function crosses the x-axis, defined by y equals 0, are found by taking the remaining numerator in the factored canceled version and setting it equal to 0. Solving for x, we have an x-coordinate of 4 and a corresponding y-coordinate of 0. There's the x-intercept. The vertical asymptotes are found by taking the remaining denominator in the fully factored canceled version and setting it equal to 0. Solving for x, we have an x equals 2 vertical asymptote. We can now analyze the asymptotic behavior on each side by taking the left-sided limit of 2, indicated by the negative superscript on the 2, analyze for the fully factored canceled version, and the right-sided limit indicated by the positive superscript on the 2, again the fully factored canceled version of the function. Let's start with the left-sided limit. The left side of 2 means less positive than 2, like 1.99. When plugged in to the factor that's making 0 in the denominator, that will be the x minus 2. 1.99 minus 2 is a negative number. It will be approaching 0, so x minus 2 can be replaced with a negative 0. The 2 can be plugged in for all remaining x's, so the numerator will be 2 minus 4. 2 minus 4 is a negative 2 over a negative 0. Negative over negative is positive. Non-zero over 0 is an infinity. And there's the left side asymptotic behavior. The right side will work in a similar fashion, but the right side of 2 is more positive than 2, like 2.01. When plugged into the factor in the denominator that's making a 0, 2.01 minus 2 is a positive. It will approach 0, but it will stay positive. We can replace x minus 2 with a positive 0. 2 can be plugged in for all remaining x's. 2 minus 4 is a negative 2 over a positive 0. Negative over positive is negative. Non-zero over 0 is an infinity. And there's the right-sided asymptotic behavior for the x equals 2 vertical asymptote. The next thing to find are any holes in the the graph. These correspond to, in the factored version, those factors that cancel so that they fully cancel out of the denominator. X plus 4 did cancel, and it fully canceled out of the denominator. There is no longer an x plus 4 in the denominator. That will then create a hole in the graph, found by taking that factor that did fully cancel out of the denominator and setting it equal to 0, solving for x. There's the x-coordinate. The corresponding y-coordinate can be found by plugging that x-coordinate back into the function using the fully factored canceled version. X minus 4 divided by x minus 2, which will give negative 4 minus 4 divided by negative 4 minus 2. Minus 4 is a negative 8. Minus 4 minus 2 is a negative 6. The negatives can cancel, and 8 and 6 can reduce by 2 to become 4 over 3. So the x-coordinate was a negative 4. The y-coordinate was a 4/3. And there is where a hole in the graph will be found.